Hello everyone, my name is Rajiv Jain and I am a senior manager with Amazon and Alexa. Thank you for your time today. Today we are going to talk about AWS integration for AWS IoT Core. This is an Amazon managed service to help you build cost-effective solutions for your connected devices and smart home. In this session, we will cover how we think about smart home opportunity and what it means to build products in smart home. I'll walk you through how you can build Alexa built-in products and how you can bring your innovations to market quickly and in a cost-effective manner using AWS integration for AWS IoT Core. And my goal for the session today is to help you gain understanding of this service and the possibilities with Alexa. Uh, I will be taking questions towards the end. If you have any questions, please type it in the chat window and I'll try to get to those questions in a timely manner. Diving right in. Smart home, as you all know, is a massive opportunity. Uh, in the last 5 years, the revenue has almost doubled from 2016, 24 billion to about 53 billion in 5 years. Also, on top, this is a trend that we see reflected on Amazon.com, where the products in this category grew almost 95% year over year. So again, a massive, massive opportunity. And what do we mean by smart home? There are a variety of products and devices that you see in your home. These are these are your lighting devices, for example, Philips and TP-Link. These could be your light switches, for example, iDevices or TP-Link. These could be appliances. A lot of manufacturers are bringing new innovations and products to market, trying to make consumers' life more convenient and connected. And Alexa certainly has a set of APIs that lets you device makers bring your products and experiences to market. And we'll go in more details in the next set of slides. What it means to add Alexa. At a high level, there are two types of integrations that are possible. First is what we call works with Alexa. In this type of integration, a user or a customer talks to an Alexa device, for example, Echo Dot, that can control a companion device, for example, in what you see on the screen, TP-Link or a Philips bulb. So in this example, a device maker integrates with a set of APIs that we call smart home APIs, and that provides you a set of primitives that can control the accessory or the companion devices in home using Alexa. And the second integration is called Alexa built-in. This is where you add mics and speakers to your product, and then there is no need to put an Echo device in your home. Your device itself can become an Alexa endpoint and can control other devices and accessories. And then there is what you see on the screen is a set of experiences that are enabled by our device makers, such as Ecobee, which is a converged device. This device is both and works with Alexa and an Alexa built-in. With this device, a customer can control not only their device, but also other accessories or companion devices in home. And with Ecobee's experience, what we have seen is our customers respond to these devices very positively. We see expanded sales, more engagement with such devices, and this is something where the installation of devices is much simpler because there's no need to put multiple devices in your home or in the room. So with the example cited, one question that we ask ourselves is why is not every smart home device, Alexa built in? Why do we see so many connected devices that are accessories or companion devices, but they're not built in? And this is really a big question. Understanding the answer to this question unlocks a truly ambient and magical customer experience where a customer does not need to talk to a specific device. And after talking to our device makers and partners, we found there were three major issues. First issue is around how the smart home devices are built. And think of this as the limitations on the smart home devices. Our device maker partners, they tell us that smart home devices are built with very limited resources on the device. Think of these as low-cost microcontrollers. These are ARM M-class processors with less than 1 megabyte of memory, and they're built with the free RTOS. And Alexa built-in devices thus far have required a much higher processing and compute resources. For example, an ARM A-class processor with about 50 MB RAM. So again, just the system requirements to build an Alexa built-in device has been much higher than what's needed for a smart home device. This translates into higher cost. Uh, when you put more memory and you put more processing, then the cost or the BOM of the device goes much higher. How many $100 light switches people are gonna want to put in their home? This is a key challenge. Our device maker tells us that, hey, we need to bring the cost of Alexa integration down so that we can lower the MSRP, the retail price for the customer, and make these devices more cost effective so they can be more ubiquitous. And then last but not the least is the complexity, where you have a large code base, which is 50 to 100 MB. It takes a lot of time to integrate, and it takes a lot of maintenance later on for device makers to be able to do OTA updates and really keep their Alexa experience fresh on the device. Uh, this translates into higher post-launch cost. And again, when you think of devices that are going to live in customers' home for 15, 20 years, this is non-trivial amount of cost that device makers do not want to commit to with a larger code basis. So again, like the question in front of us is, hey, how can we bring a truly magical and ambient Alexa experience into smart home devices at a low cost? And the answer that we had from Amazon was, why don't we offload the compute and memory resources instead of putting a lot of compute and the memory on the device itself? What if we virtualize that? What if we offloaded all of that compute and memory from device to the cloud, and then create an experience which does not create too much latency or headache for our customers? And then adjacent to that are the problems, like once you create these devices, how do you think about the lifetime OTA updates and maintenance of these devices? How do we make it super, super simple for our customers? Uh, and this is where we collaborated with AWS to expose this functionality through AWS IoT Core. And what this does is it lowers the cost of making these devices. Instead of adding a big ARM processor, now you can add a tiny ARM MCU with very limited RAM. So instead of external RAM, you can have whatever is available on the chip itself, up to 1 MB RAM. And with this, you can reduce the cost, and you can reduce the complexity of the product. With the reduced cost and complexity, device makers can enable multiple different device types, such as coffee makers and appliances. It simplifies the software development. And then we worked with our partners, chipmaker partners, such as Qualcomm and NXP, to make it really easy for our device makers to get started. And we're going to talk a little bit more about it later today. So from a how you get started. So as I said earlier, this is the AWS integration for AWS IoT Core is a reserved topic in AWS IoT. As a device maker, you create a device with very limited memory and RAM, and then you connect to a reserved topic in AWS IoT Core. AWS IoT connects to the Alexa infrastructure internally, and simplifies the directives and events that you need to exchange between your device and the virtual device in the cloud. So as a partner, you don't have to think about the management of the virtual device. That's all taken care by the managed service itself. all you need to do is connect to the AWS IoT Core. So for those who are familiar with Alexa and AWS C++ SDK, that's open source code on GitHub. What you see here is a logical representation on the screen. Uh, at a high level, think of this diagram in two blocks. On the left hand side is the audio, and then on the right hand side is the control. Uh, so this is what's needed on an AVS device, traditional AVS device, to be able uh, to create an Alexa built-in experience. I I won't walk you through all of this, but I'll give you maybe just a couple of anecdotes. On the left hand side are blocks such as audio processing and wake word. Think of these as the blocks that are needed on the device to be able to clean up the voice and listen to the wake word. This is something that's baseline experience for all Alexa device. In a typical far field implementation where a device should be able to hear you from 20 to 30 feet in a noisy environment, you need these blocks to create a good customer experience. And then once a device hears you, it establishes a connection with the AWS Alexa cloud. Uh, it sends the events up, receives a directive, handles the directives, and then controls the audio. So again, think of this as on the left-hand side as the audio, and then right-hand side as the control blocks. With the new service, we offloaded almost an entirety of the control blocks from the device to the cloud. So now what you need from a device maker standpoint is just the ability to process and send audio to the cloud. Think of that as a long wire between your microphones and speakers. All the complexity of handling the communication with Alexa, cloud, and ability to manage directives and events is all managed by the cloud. I'll give you maybe a couple of examples. A typical Alexa device uh, is capable of playing music from multiple sources. What that means is you, as a device maker, you need to implement multiple codecs on your device. Uh, these codecs add to complexity on the device and then takes a lot of compute and memory resources. With AIA, we uh, we moved the audio transcoding from the device to cloud. As a device maker, all you need to do is implement uh, Opus decoder, and then the cloud sends your device 64 kbps Opus. And whether it's music, whether it's audio, whether it's alarms, everything's is encoded into 64 kbps. And as a device maker, that's all you need to handle. So all of the complexity that's in the was on the device before has now moved to the cloud. And we'll talk a little bit more about what this means. So now with the AWS integration for AWS IoT Core, as a device maker, you can simplify your implementation a lot. Uh, if you want to create just a push to talk device, think of that as something where you press a button. You can keep that pressing that button, or you can hold, or you can just tap and you can release the button. That's called a touch initiated interaction. Uh, in that case, all you need is AWS IoT SDK. You need a lightweight media player for Opus, and you need to be able to do some buffering and authentication. And that's it. With this, you can create an Alexa built-in device with just an ARM M4 processor with 500 MB RAM, KB RAM. That's really tiny. Think of this as maybe in a less than $2 system BOM, you can have this Alexa built-in capability. On the other hand, if you want to create an Alexa far field implementation, far field is where you can talk to a device maybe 20 to 30 feet away, and you can say the word Alexa and the devices in the vicinity will respond. Uh, then you will need to add on the wake word and the audio front-end processing. Think of that as noise suppression, beamforming, some sort of echo cancellation. Uh, all of these is required so customers can talk to Alexa from far away in a noisy environment. Uh, And that's all doable in our ARM M7 class processor with less than 1 MB RAM. And we have examples of both that we're going to share later today. Talking a little bit more about the hardware footprint. Uh, what you see here are the different classes of Alexa built-in solutions. AWS for IoT Core on the left-hand side, and then all the way to Smart Screen SDK, the SDK for TVs and smart screen devices on the right-hand side. And this is just a quick way to compare and contrast these solutions. Maybe just a couple of areas where I want to draw your attention today is look at the processing in RAM. Uh, in AWS, the AWS integration for AWS IoT Core, all it requires an M7 with about 1 MB RAM. And then if you look at the Smart Screen SDK, you're going to need an A-class quad core with about 256 MB. So again, very different system requirements for different class of user experiences. Connectivity is Wi-Fi over MQTT, and we're going to talk a little bit more about MQTT protocol and why later in the call. Uh, whereas the AWS device SDK and Smart Screen SDK require HTTP2, which is a much heavier library and interaction. And then, and typically the applications that we have in mind for AWS integration for AWS IoT Core are these smart home devices such as light switches, thermostats, appliances, where the expectation is more of a voice-oriented, audio-oriented interaction versus full music. Uh, and that's where you see the feature set as well, where the AWS integration for AWS IoT Core provides the alerts and dialogues and maybe lightweight entertainment options versus AWS Device SDK and the Smart Screen SDK, which are more optimized towards multimedia and entertainment options. We uh, switching gears to help our device makers go to market quickly. We partnered with uh, some of the largest chip makers in the world. An example that you see here is an XP. Just because the AIA integration simplifies the interaction with Alexa Cloud does not mean as a device maker it's easy to go to market. You still need algorithms such as wake word, such as far field audio pickup. And that's where our partners such as an XP, uh, they they do a phenomenal job in bringing together a production ready solution where everything's implemented for you as a partner. You can, instead of starting from scratch, you can procure this kit. This kit has the MCU based Alexa solution. It has the 3 mic far field audio algorithm. It has the Amazon wake word. It's qualified, it's tested and qualified by AWS. As a device maker, instead of playing around with the APIs and dev kits, you can procure this kit and you can take use this solution and go to market quickly. And we have a case study later that we'll talk about, which is iDevices, who took this NSP kit and went to from concept to production launch in less than 6 months. Next example I have is Qualcomm. Qualcomm is another dev kit that's fully qualified by AWS. And this is a solution which has an MCU plus a DSP based solution. Uh, so this kit has a different level of integration. This is based on a Qualcomm SoC, which has the Wi-Fi. And then whatever leftover processing capacity was remaining is utilized by the Alexa, the AWS integration. And for the noise suppression and wake word, Qualcomm implemented a DSP-based solution. So it's an M4 plus a DSP. Uh, and it has all the necessary blocks for you to take this kit and go to market. So it has the AWS qualified solution, it has the wake word, it has the noise suppression, and you can see the link to this kit on the bottom of the slide. You can procure this kit and you can go to market quickly. Moving on, this is the This is the case study I referenced earlier in the presentation where we worked with the device maker iDevices. Uh, they took the NXP kit and they created an amazing Alexa experience on top. This is a light switch that has the Alexa implementation. It's built in. So when you put this in a space, you can control your lighting or appliances or anything that's connected to the switch just with your voice. You don't need an Echo Dot or any other Alexa built-in device. This has both the works with Alexa, so it's a skill to turn on, off, and off the switch, as well as the built-in. So it has two mics and a speaker. So this device in itself can play music, can control your smart home devices, uh, can toggle itself on and off, and it can provide a really good Alexa functionality. This is available on Amazon.com today. Uh, this switch also brings together AWS IoT Core for management and security. And I won't read the whole slide, uh, but this just makes it much simpler and faster for the device maker to go to market instead of worrying about the integration with multiple different components for application, for security, and for management. Pricing wise, as I mentioned, AWS integration for AWS IoT Core is available as a reserved topic in AWS IoT Core. This topic is a reserved topic and it's not metered, which means your AWS account is not built for any messages back and forth between your device and Alexa service uh, for Alexa built-in experience. All you need to do is connect to AWS IoT Core, and then the usage of Alexa on this device is free. We realize that at Amazon, just getting Alexa integration working on your device is part of a solution. As a device maker, you also have needs to be able to connect to cloud, to be able to manage your device fleet, to be able to secure your devices, and to be able to analyze how your device fleet is doing. And that's why we chose to do this integration with AWS, so that as device makers, you get all the best in class connectivity, analytics, management, and security solutions. Uh, Visit AWS IoT Core today, and you can learn more about the capabilities and the pricing of AWS. In short, the solution that's offered by Alexa is just an application on your device. And AWS integration for AWS IoT Core makes it really, really easy to get that application running on your device. You can do it yourself. You can start with one of our dev kits, uh, or you can work with one of our partners such as Qualcomm and NXP, and there are more coming. Uh, and then Amazon makes it easier for you to manage and secure these devices using AWS IoT Core, and then provides the operating system, Amazon FreeRTOS, which is really the best-in-class operating system for microcontrollers. Uh, so you get the application, you get the operating system, and then you get the connectivity, management, and security stack, all to make it easy to build connected devices. Here are some helpful links in so that you can after this presentation you can check out the AWS blog about AWS IoT Core. We have a really helpful getting started guide that can point you in the right direction, and then the API spec is also available on Amazon.com. You can also order the NXP kit by visiting the bit.ly link at the dev kit window, or you can also check out Qualcomm. With that, thank you very much for your time today. I will be taking next few minutes to answer any questions you may have. And if you have any other questions or you want to connect with me, you can reach me at uh, my name is Rajiv Jain, and you can reach me at jrajiv, Jai, rajiv@amazon.com, and I'll be happy to answer any follow-up questions you may have. Thank you very much for your time today. I really appreciate it.